In this video, we're going to use power series to help us evaluate a limit. So we have the limit as x goes to 0 of 1 minus cosine all over 1 plus x minus e to the x. Probably the easiest way to do this, at least in my mind, is to just write out the terms of the series, some of the terms of the series, and start seeing what happens when you simplify things. Certainly we cannot just plug in 0 for x because we get 0 over 0, which means we need to do more work. In this case, the more work will involve plugging in some power series and seeing that we'll be able to factor out some powers of x that will cancel, and then we'll be able to evaluate the limit. All right, so our Maclaurin series for cosine is this one. It's 1 minus x squared over 2 plus x to the 4th over 24. The next term would be x to the 6th over 720. Remember, it's negative 1 to the n, x to the 2n over 2n factorial. Also, our Maclaurin series for e to the x is 1 plus x squared over 2 plus x cubed over 3, and so on. Remember, the Maclaurin series for e to the x is x to the n over n factorial. All right, so now let's do some simplifying. 1 minus 1 will give us 0. Distributing the minus sign through will flip all the signs in the numerator. I should say flip the remaining sides of the numerator. The denominator, the 1 plus x's will cancel, and this negative will distribute all the way through and make them all negative. So we'll get x squared over 2 minus x to the 4th over 24, and so on, divided by negative x squared over 2 minus x squared over 3 minus, and so on. We can factor out an x squared on top and bottom. Actually, I'll go ahead and factor out the negative sign at the bottom as well. On top, we get left with a power series that starts at a half. On bottom, we also get left with a power series that starts at half. Not the same power series, but they certainly both started at a half. In this case, again, remember that we're trying to evaluate the limit when x is 0. Now I can plug in 0 in the top and bottom. I can evaluate this limit through direct substitution because all of the rest of the terms in the power series will have some positive power of x on them. So we'll get 1/2 on top. We'll just get the constant on top, negative 1/2 on bottom, and that quotient equals negative 1.